So this talk is actually about making Smalltalk continue to be great as well. So I thought it was a very great lead-in. I'm going to talk some about the history of Smalltalk, some of the things that happened, and I'm also going to talk about where I think actually a mistake was made in a sense. A mistake was made in the past, an incredibly influential mistake, and how I think Smalltalk ought to go in the future. I'm focusing on the image, the Smalltalk image as an idea. I'll say my name tag says University of Illinois. I'm officially retired from the University of Illinois. I get a pension, which is sort of nice. I've started a startup called Metafficient, which is nice. I get a pension because Metafficient doesn't make any money yet. So at the very, very early stage. Unfortunately, Metafficient doesn't use Smalltalk. So it'd be great to say here's a great Smalltalk system. But I use Smalltalk in teaching my entire career, and for most of it, I'd say the first two-thirds it was the Park Place Smalltalk and VisualWorks. Actually, I used Tektronix Smalltalk for a while, and then was using Squeak for the last 10 years or so. So actually, a lot of my VisualWorks knowledge is out of date. I'm sure there's a lot of stuff happening there that I don't know about, but I'm going to be making comments anyway. This is sort of an outline. I was surprised to discover that I was the lead-off talk because this is not polished. I've not actually talked about a lot of these ideas before. So anyway, I'm trying them out on you. So there's a lot of things that Smalltalk originated or was a major part of the origination. So the whole idea of the WIMP, the Windows, mouse, pointer. Now, Windows had been invented before, a mouse. All these things had been, M is menu pointer. The idea that you have your window and you point to something on it and you get a pop-up menu and you select it and that's an operation on it. That whole Smalltalk was the first system that put it all together and built a whole system based on that. These things had been individual ideas. It was at Xerox PARC in the early days. They had made a personal computer called the name escapes me. Someone tell me. Excuse me? Alto, yes, the Alto. So the Alto was a desk. They knew that someday a computer would sit on a desk, but they couldn't make computers for that small yet, so they made a whole desk that was your computer, and they gave one to each person. They cost like $100,000 back in 1970, and of course the executive said, this is ridiculous, why are we but no, everybody must have their own computer because that's the way the future will be, and we got to be prepared for the future. We must learn what the future will be like by giving people the computer of the future now, and then we can learn how to write software for it. So that was the idea. There were actually 3 groups at Xerox PARC, all making their own software. So one of them was more of a Pascal-ish type system, and they invented the Internet and the Ethernet. They did the Ethernet and the idea of file servers, remote file servers. They had the first laser printer down the hall, which of course they took a Xerox machine, put a computer, because they made them after all, put a computer in them and to drive it. And so, but where the Smalltalk group, then there's a Lisp group, there was more AI, Common Loops, I think was the name of that. And then you had the Smalltalk group. And the Smalltalk group was focusing on the interactive, how you learn with a computer, and trying to make make graphics really easy to use. And so they did the user interface stuff, which promptly got stolen by the other 2 groups, right? Because they're all in the same building and they all talk to each other, go to lunch every day and look at what each person is doing. And so it actually started spreading out through the first products that came out from Xerox were from the Pascal-ish group. And so there's a Xerox Star was a product they had. And I was a grad student at Cornell, and they gave us a bunch of these Xerox Stars, and they were great for doing word processing and all. And I didn't realize at the time, but that was already the second generation inside Xerox, sort of coming from the Smalltalk group, even though it was this Pascal-ish type language. Okay. Oh, and Steve Jobs, when he went to Xerox and he saw this stuff with Smalltalk, but probably also the Xerox star. He was so impressed, he went back and said, we must make our computers this way in the future, and then that was eventually the Mac. Actually, they did the Lisa first, which failed, and then they got the Mac out of that. But, which is the story of technology. You get a great idea, you get so excited, you go off and you do it, and you fall flat on your face. And you say, but it was a great idea, it's got to work. And you go and you do it again, and maybe a third time, and finally you get it to work. So that's the way things really work. You just don't hear about the failures. You only hear about the successes. You don't hear about the 10 attempts people made before to get it to work. Browser. The word browser came from Smalltalk. Now we talk about internet browser. Now why do they use that word? Well, the Smalltalk people, they not only had the browser for code, but they would talk about browsers for this and browsers for that. And the Smalltalk browser, when people saw it, it was like, oh, this is a different way of looking at code. And now Eclipse and all these tools, they all sort of do it similar ways. And we look at the browser, original browser, and say, boy, that looks really antique. No. If you were back there in 1985 seeing it, it was mind-altering. It wasn't, it looks old-fashioned now because so much has happened since. A model view controller. There was a Norwegian professor on sabbatical, went to Xerox PARC. He worked on doing ship design, automated ship design. He was working with companies in Norway to automate their shipyards and ship design process. And so he was trying to figure out better ways of doing software. And he went to Xerox to joined the Smalltalk group for a year and saw how they were doing and how they were building user interfaces. And he came up with the idea of model view controller, which then had an impact everyone else. I mean, I think they were sort of doing stuff like that, but he had a way of describing it, and that helped people in designing things. And what you see today on web systems, when they call model view controller, is of course not quite the same thing as was done back in Smalltalk. It's sort of, people take an idea and change it a little bit and change it a little bit and change it a little bit, and it passes on. But it was the name absolutely came from Smalltalk, and the ideas were worked on and created and evolved inside Smalltalk a lot. So framework is a little bit more controversial because I've seen systems in Simula. So Simula is the first object-oriented language, but it wasn't called object-oriented. Smalltalk, I think, was actually the first language where people called it object-oriented. But when you look at Simula and Smalltalk, there's clearly a relationship between them. And there's systems. They just called them like extensible applications, or they had different names for it. And in fact, even when I got into Smalltalk, and I was trying to figure out why you could reuse code so well in Smalltalk, people weren't using the word framework. The Tektronix people were. I talked to people in Xerox Special Information Systems, and they had a big system with lots of frameworks in it. They had a different name for it. I can't remember what their name was. It wasn't very catchy. It was one of the things, they tell you the name, and but when I went to, what? Excuse me? It was the analyst, yeah. It was called, the analyst was a system, but they had a name for a framework within their system. I don't remember what they called it because, like I said, it wasn't a very catchy name. They had the idea, but they didn't have the name. I went to Tektronix, where they had a big Smalltalk group, and they called them frameworks, and they said what they were and talked about the problems with them. And then Mac App, and Apple, the Mac App was the Macintosh Application Development Framework. And so that, I think, it was actually Apple that popularized the word framework, but I think they got it probably from the same place Tektronix had. But it was a word. People, there's an idea, there's a word, we have vocabulary, we need to have good names to talk about things, and working all that out takes time. Takes time. So something that a lot of you don't know, it's actually a very useful design technique. CRC cards was invented by people in Tektronix for, and was really widely used in the 90s for people to learn object-oriented design. Do any of you guys learn it in school anymore? Because I was always teaching it in school. about students now? You learn, so some people, you still see it. I mean, it's a good, easy technique. Doesn't involve any technology. So it shows that object thinking isn't about a particular programming language. Helps you. And also, some people overuse drawing pictures. It's also not necessarily about drawing pictures. So, I mean, drawing pictures is fine, but that's one of the things about CRC cars. No pictures. It's different. The whole X unit, J unit, and all the different test frameworks. Now, of course, you've seen S unit, and people normally think, well, S unit obviously came from J unit. That's not what really happened. What really happened was that Kent Beck made a framework. He called it the Smalltalk Testing Framework. That was the name. And I used it. And he went to Switzerland, and he was working with various people there. And one of the people that he wanted to work with was Eric Gama. And they were doing a little project. He said, well, let's do a test framework, which he already had built test frameworks before, so he knew how to do that pretty well. And that is one of Kent's little. He's going to work with you. He'll work with you doing something he already knows how to do, so he looks real smart. It's a clever technique. We all can use that. So they built this together, and they called it J Unit. And Eric. The two of them together wrote some papers on it and got various groups to use it and got really popular. It was a great idea. So a lot of people think that JUnit was the first one. Well, it wasn't called SUnit in the beginning. It was called something else. But I used the code before they wrote those papers, before you even went to Switzerland. So I know that it was done in Smalltalk first. Refactoring. Again, I wrote the first paper that had the word refactoring in it. So my students did. We did a lot of work with refactoring, a lot of papers on refactoring, and the Smalltalk refactoring browser was done by some of my students. So, but I learned the word from people at Tektronix. So as I was, again, learning how you make frameworks, how do you come up with them, and the guys at Tektronix were talking about frameworks a lot, and I would go around and talk to different groups, and I'm pretty sure that the refactoring word came from there. And the whole idea of refactoring, I remember Bill Updike, PhD student of mine, and was the first student to work with me on refactoring and making lists of stuff. And he was from Bell Labs. He was more of a Lisp programmer, but he knew Bell Labs, that C++ was important to Bell Labs, and so he was the thesis he wrote was more based on C++. But when he actually went and tried to talk to C++ people about it, they were not enthused. I mean, they thought this idea of refactoring was sort of crazy. You know, once you publish an interface, you can't change it because there's people out there who use it, and you're just stuck. Now, that's, of course, you can say that all you want, but people are going to change it anyway. That's what happens in real life. And the Smalltalk folks, they just knew that stuff changed all the time, and having language for talking about the change and having tools to help you manage the change, that was good because it was going to change. Whether you like it or not, it was going to change, and you needed to manage it. And refactoring gave you tools, intellectual tools and software tools for managing it. So it actually, the Smalltalk community embraced that. Even if they weren't using the word, they got into that. And that's why we ended up making a tool for Smalltalk first, even though nowadays people tell you, well, you can't write a refactoring tool for a dynamically typed language. It must be statically typed so that you can use that type information to change the code. You couldn't possibly write a refactoring tool for Ruby, say, or because dynamically typed languages, it just can't be done. Well, that's ridiculous because the very first one was done for Smalltalk. And of course, XP, Kent Beck, was trying to describe a way of building software that he had learned in Smalltalk. And so it's not fair to say that's a Smalltalk way of doing things, because Smalltalk is doing it all different ways. There's lots of different ways that you can develop software in Smalltalk. But it is true to say that the XP came out of Smalltalk projects and Smalltalk people, even though most people who do that now aren't using Smalltalk. Okay, so that's a bit about a lot of different things in the past. I want to talk about one more thing from the past and how I think it ought to change, and that's the idea of the image. And if you are a fairly new programmer and the first programming language you ever learned was Smalltalk, then the image doesn't seem particularly weird to you. It's just the way things work. And then you start looking at other languages. You say, boy, these are really brain-dead languages. But if you start off with C, and then you come to Smalltalk, the image seems weird and sort of weirdly wonderful, but still pretty weird. There's a lot of strange things about it. So it's actually a database. It's got all these objects in it, and the objects are running. They're live. And when you save it, it goes out on the disk, and then you bring it back. They're exactly the way they were when you saved it, including windows being open, files you're connected to. All these things are supposed to get connected. So you're saving that snapshot of what you're doing. And so the objects include your code, because classes are code. So some of the objects that are in there are actually your code. And then it includes tools that you're using. So when it comes back up, if you've opened 3 browsers, you've got a debugger and 3 browsers, they come back. You're debugging the same method halfway through executing that method. And, again, if you've never programmed any other way, it's like, well, isn't that how it ought to work? But if you are used to other environments, it's like, this is just bizarre. How do they do that? I can't imagine how you can get that done. Now, it turns out that some things are actually pretty tricky. There's tricky code underneath there to make it all work with things like the files and windows, because there's stuff out in the real world. You have to reopen a file, and what if you've moved the image, and now or somebody deleted the file while you had closed the image down. Now you pop the image back up, and it wants to have that file. How do you make sure that Windows, if you've got a native host window operating system, so that the windows in Smalltalk correspond to windows in your operating system, you have to reopen those operating system windows in order to get. So there's tricky stuff that goes on to create that illusion is the wrong word, to create that reality. It isn't an illusion. It's real, but it took some work to get all those things right. And of course, all your application data. That's sometimes the easy part, but if you're an application programmer, that's the important part. Because it's actually a very simple type of database. You can save the whole image and start it back up, and people often do that. They don't bother to write any real file saving routines. They just use the whole thing as a database. So some of the benefits are that being able to remember how your windows are laid out. You actually can use your window placement and stacks of windows as a to-do list, as your work, what you're planning to do. When you're going and refactoring code, when you realize that you don't know quite how to solve something, put up a window and put it over here as a list of things you have to do. You can come back and look at it later. You won't forget it. It's going to be there. The whole system is actually very compact. In days now, memory's not much of an issue. We don't think about that as much. I can remember years ago I was going to, I think it was an XP conference, and I was doing a project. I was converting code from one Smalltalk to another Smalltalk, and I can't remember. As probably Visual Works and Squeak, but I don't know which way I was going. But I would have to run both of them simultaneously so I could sort of see what was going on and change stuff in one to make it match what was going on in the other. And somebody borrowed my laptop to give a talk. His machine died. I said, well, I've got PowerPoint on here. You can use my machine to do that. Well, his talk ran pretty slowly. He had fancy animation. Turned out my computer was the slowest computer at the conference by a factor of 2. I was using some ancient Mac. I would buy laptops on eBay used pretty cheap, and I think at the day it had 64 meg of memory, which, I remember programming in Smalltalk with 5 meg and thinking that was a lot of memory. So 64 meg, I could run 2 Smalltalks simultaneously. And I couldn't run Word at the same time, but, I could run 2 Smalltalks simultaneously. And well, this is the advantage of having a really compact, efficient language. And you realize there's it's your compilers. And of course, I use Eclipse now. you run Eclipse, it takes a gigabyte of memory to run Eclipse. I mean, I can't understand how it can use that much. It blows my mind. But the Smalltalks have gotten bigger over the years, but still, compared to everything else, they're very compact. And you can extend it. So people love this about Smalltalk. Everybody can add their little bells and whistles, change how the debugger works, change how, if you don't like the way the browser, you can change something. Source code's all available. It's all there. And so application programmers can customize the environment. And like I said, a simple persistence, you can just save the entire image, use the image as a database. But application, one of the things it says is that applications are extensions of the environment. Now, applications aren't these standalone things that you normally think of. They depend on the whole image. They depend on all that other code. And that's good because it lets you build things quickly. It's bad because sometimes you want it to be independent, or the next version of your Smalltalk comes out and they change something up there that you're depending on, and it breaks what you've got. Applications interact. And that's good if you're, again, trying to make your applications interact. But if there's a bug in one, it can influence another one in ways that you might not have expected. The boundaries of applications aren't well defined. That's just a fact. And again, there's advantages to this, but there's disadvantages too. And that's my point. We've actually, over the years, developed lots of tools for dealing with the fact that there aren't these boundaries and trying to impose boundaries on our software. So when you think about the Smalltalk, the image as a database, obviously the fact that it's single user is a major problem. So you can talk to a real database, and it takes a lot of work, to change from thinking about everything in memory and we just save the whole image to now we're going to have to go talk to a database and save our data on the database. But now multiple people can use the database and you get more of a multi-user. And there are other ways of dealing with multiple users, but the Smalltalk image is inherently single user. So you get a lot of benefit as long as you're in that paradigm, but you try to step out. You've got to do some more work. Interesting thing is that the behavior of your system is, of course, defined not just by your code, but also by the data in the system. And you see that some years ago I was involved with Squeak trying to take eToys out, where you could, as a package, could file it back in. Well, the problem was a lot of the behavior of eToys was in class variables. It was in various data that had been initialized a certain way. And if you'd save all the classes and then file them back in again, it didn't actually work. And people were trying to figure out, well, how do we have to initialize these classes so that it will work when we file them in? The behavior of the system was more than just the code. And yeah, it's a problem. And because the programming environment is mixed with application, maybe you didn't want to let people debug the program. Maybe you didn't want, when they were running the program and some error occurred, that the debugger would pop up and they'd be able to go in and look at things. It sort of hurts security, trying to keep information private. So, of course, we have standard ways of turning off a debugger, and I mean, it's a problem we have to face, but it shows how different. In the C world, you have to put on flags on your compiler so that you can debug your program. And, excuse me? I got 5 minutes. I thought you'd given, the schedule said an hour, didn't it?
Yeah, but 30 minutes.
Okay.
But, I mean, give me 1 hour.
Okay. I guess I misread the schedule. And of course, having all that bundled in takes memory. So we have ways of stripping, removing the tools from the environment. The easy to break the programming environment comes if you can put a breakpoint. You think you're debugging your application graphics, and you're putting breakpoints in the user interface, and you put a breakpoint in the wrong piece of user interface, a part of the user interface that the debugger uses. Well, then when you pop up a debugger, it hits that, and you're in an infinite cycle of, all these guys laughing. We've all done it multiple times. And one of the things it teaches you is what's the core part of the user interface versus what's the less important part. So I can put my breakpoints here. I don't want to put my breakpoints there. Also teaches you how to recover from changes from crash, which is a good thing because you are going to crash. But and again, when you're an expert, this is not a big deal. It's a part of the way the system works, and we all know how to deal with it. It's different from other systems, and that's the real point. It's a sort of a unique thing. One of the things I would tell students is the image is wonderful. There's all the stuff you can do with the image, but don't be seduced by the image. Don't let it fool you. And one of the things you have to be able to do is recreate your image. You want to have some script that you can run to rebuild things. And my general rule, just to make sure that I always could recreate the image, was every Monday, throw away my old image and start it up and make a new image, and then I could run it all week long and just save it and keep on going. But that seemed to be good enough to make sure that I didn't get stuck in my image. And I had a PhD student whose work remains unusable because he had one image for like 3 years and he never made scripts for it, and so he can't remove the stuff from the image. I mean, you could with enough work, but it's just not enough work. And the debugger itself is pretty amazing. How small it is. This is actually a secret of building embedded debuggers, of having, when you're building some application, if you're building an application, some new language, you can actually build a debugger inside that application. There's a lot of advantages from it. And if you study the Smalltalk debugger, you'll learn how to make debuggers. It's great that the source code is all there. Most people don't know how to make a debugger, but Smalltalkers, a lot of Smalltalkers do, because you get an urge to fix the debugger. There's something about it you just don't like, and you're going to make it right. And you go in, and several weeks later, you actually are able to make that 3 lines of code change and get it to work. Because the debugger is a little tricky, but it's good intellectual exercise to figure that out. And of course, it's an amazing thing of being able to write your program in the debugger. And other debuggers now are just starting to get to the point where you can actually change, debug and change code in the middle of debugging it. But that's been something that the Lisp world's been able to do that, but most of the languages haven't been able to do that. Okay, so I already said about this. Okay, so the main thing I want to talk about was this idea we get in the image that all the objects are we have this world of objects, universe of objects, and the image has all the objects in the world in it, one address space. And that, Smalltalk itself the language doesn't have modularity in it. People talk about that. And so you have to think of design patterns that we use to impose modularity and talk about this subsystem versus that subsystem. The programming environments. So our programming environments will often give us some packaging form, and you use those packages as a kind of modularity. So the fact that we don't have that makes it easier to reuse code, it's easier to change it, but also it tends to increase coupling. If you aren't watching what you're doing, you end up with a connection between packages that you weren't expecting. And people often are saying, I try to take the original model view controller code out of Squeak, and this thing broke. And why would it break? It seems to have nothing to do with that. Well, it's some little hidden thing. My complaint here, is it encourages an unrealistic view of distributed computing. So back in the 80s and 90s, we were trying to make distributed programming be completely automatic and invisible. And you just take any object and you can say, well, this is going to be over on that machine there, and it's just going to work. And people built systems. Some of the first systems are actually in Smalltalk, because it was pretty easy to build systems. So where you had to figure out when you have an exception, how you propagate the exception across machine boundaries. But you inspect an object over another machine, I had students who did that. But what happens is, from a practical point of view, it's not that useful, because you take a design that worked perfectly good on this one machine, and then you try to distribute it, and you realize that there's way too many messages going back and forth. In a distributed world, your message send costs 1,000, 10,000, 100,000 times as much as it costs in Smalltalk. Yeah, a few zeros or a few orders of magnitude make a big difference in the performance of your system. And also the fact that a machine could crash on the other end, so you have to deal with message never returning. It can happen in Smalltalk too. You get an infinite loop and it'll never return, or raises an exception and blows it away, but it's a much bigger deal. So I claim, this is a big deal I want to make, is that we should think of an image not as the universe. We shouldn't think of the image as a universe. We should think of the image as a unit of modularity. We should think of building systems out of a lot of images that talk to each other. And that we should, so an image is a component. And that consequently, we should know that this object is in my image versus, or is in this current image versus it's in the image over there. That's something we should think about. And we don't need to have the exact same interface for talking to objects. Sometimes it's helpful to have the same interface. And build proxies, the idea of proxies is a great idea. But you don't want to, that shouldn't be your highest calling. You shouldn't say that our goal is to have this sort of transparent distribution. Because distribution is never going to be completely transparent. I think one of the things you want to be able to do is that one image should be able to control another one. You should be able to have a hierarchy of images and have a development image that can go out to another image and can debug it, can insert code, can change code in it. And again, like I know that VisualWorks, back when I was using it, was having some ability to do this. Probably it's better now. But in the Squeak world, that hasn't happened. Craig Lotta's got Spoon, and that does some. So that's a little fork he's got, where he's got some features like this, one image being able to control another one. But this is not something that people have been looking at in general. Okay, so the reason why I want to do a little more 5 minutes, I want to talk about a really important book. How many people have read Domain-Driven Design? Okay, not too many. So this is a really important book. And Eric Evans is another small talker, just like Martin Fowler. He's a small talker too. Yeah? He never mentioned small talk in the books he writes, but his ideas. He was a long-time small talker, and you'll just see it awful as a young person. You're saying there aren't that many companies that are hiring small talkers. Of course, the companies here that hire small talkers are saying, yeah, we need more people. We need more people. But still, it is true that most companies are using other languages. As an education, there is no better education in object-oriented design that you can get than learning Smalltalk and becoming good at Smalltalk. It changes the way you think, like nothing else will. And you'll see a long list of famous people who you don't think of as Smalltalk people. No. They're Smalltalk people. And the one thing about the Smalltalk people, even though they haven't programmed in Smalltalk for 15 years, if you say, are you a Smalltalk? Smalltalk is a wonderful language. So I loved when I was using it. It was just a great experience. That's what they're going to say. They're not using Smalltalk anymore, but they're always Smalltalk people. That's the way it is. Okay, so this book is about how we say that our design of our system is supposed to match the problem domain. The kind of problems we're solving. We want to have objects that meet up with the problem. But the problem is, so if you read some design, say, well, first learn the problem domain, then you sit down and you make your design based on that, and then you can generate your code. But of course, then you work on the code for 10 years. When do you really understand the problem domain, or when do you understand the problem domain best? You understand the problem domain best on your last day on the job. You just keep learning. Every day you know there's the problem domain better than the day before. So how can you design a system that's based on a problem domain when you're going to learn so much more about it by the end of the project than you know now? It's just philosophical difficulty, existential problem. But it's reality, and it doesn't change the truth that we want to design our systems based on understanding the problem domain. It's just our problem domain will keep changing, and so our design of our system has to keep changing. So this is a book about refactoring, but refactoring not based on just reading code and looking for little patterns in the code and tweaking them, but on our understanding of the system and changes. So one of his key ideas is ubiquitous language. The language is a language that the people on the project, both the users and the developers, use to talk about the system. And small talkers have always said class names should be and method names should be based on the user's language. We'll say stuff like that. But in fact, it's not entirely true, because a lot of times the users don't even have words for it. You got to invent some vocabulary. When they do it by hand, they don't need language. But now we're going to automate it. We got to have language, and so we jointly, together with them, come up with a language. And so it's not one-sided. It's not that just talk to the users, they'll tell you the language, you write it down, that goes off. That's not the way it is. You develop this language together. And that ubiquitous language should be used everywhere, including your sales literature, your PowerPoint, the test scripts, everything you do should include that, and you change your mind. So now refactoring isn't just going in and changing your code, it's changing your PowerPoint slides. It's changing your marketing literature. It's everything has to. When you decide this was the wrong way and now it's going to be something different, you need to change. You change your language, and that changes your model, and that's changing everything you're doing. So a key idea I want to talk about now is he has a bounded context. When you have a big system, everything will not be consistent. It just won't be. A big company, everything is not consistent. I was working at Caterpillar, and we had this problem, or they're telling me a story about a problem they had where one division said that they were shipping things in time, and the other division said, no, you're not shipping them in time. No, they're coming in late, you're not. And so the problem was they had a different definition of shipping date. Okay, so a consultant came in and they were arguing which is the right definition of shipping date. Blah, 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 back and forth. Which is the right? They said, let's do a survey of the whole company. 5 different definitions of shipping date in the company. And nobody knew that before. But that's reality. That's just the way the world works. You can't assume that you'll go out and discover the correct definition of shipping date, because there isn't a correct definition. And this is a problem in lots of life, that we have different definitions of the same thing, and we don't even understand that there's a difference. So part of it, he says, you define a bounded context. It's a part of the system that has this ubiquitous language where everything is consistent, and that way you map it out. He talks about a context map. There's this part here, and this part here, and these guys have this definition, and those guys have that definition, and figuring out how it all fits. A very key idea. And then he's got a bunch of patterns. This is a great patterns book. So I'm a patterns guy. So DomainDriven Design doesn't have patterns in the title, but it's a great patterns book. He has a bunch of patterns for how domains fit together. So you could have a single bounded context, and there are some small systems that are just single bounded context. Or if you have 2 bounded contexts, they share a whole bunch. You make a shared kernel, you're supposed to actually define that as a new bounded context, have like one member from each team join together and jointly work on managing your shared. It might just be an interface between 2 systems. It might be some shared library that they have. But the customer supplier team is where one context uses another, and the people who are developing the context listen to the people who use it. And if the people who use it want something new, they will make changes and design it for them. And it's a wonderful relationship. Oh, that's a great group, gives us just what we want. Because you also have the anti-corruption layer, which is where the group you're using doesn't care a bit about you. They work for some bank somewhere, and they're shipping you stuff. And they change it without ever telling you, and you just have to protect yourself from them. So you build big layers of translation stuff because those idiots. Yeah. And then the conformist layer is maybe you use Microsoft. And Microsoft, you love their libraries, and every 5 or so years, they have a big release that comes out, and then you have to change everything so that you will work with it. It really isn't any different if you're using a smalltalk image. A new version of the image comes out, you're going to change your stuff to use it. You're not protecting yourself from that. You're using it, you're basing yourself on it. You're conforming to what this other group does. So they aren't necessarily asking your opinion, although I say Microsoft actually has thousands of people who go off and ask opinions and do surveys of all their customers trying to figure out, but you as a single user, they're not doing it just for you. They're making the decisions based on however they want. Anyway, so there's a whole collection of these things. And the point I want to make is, when you understand this, you realize Smalltalk excels. It absolutely excels at making a single bounded context. When everything is going to be consistent, when it's all in one world, and you can, and you have a small team, because one of the things he says is you have one team per context. And a team can sometimes manage a couple of contexts, but typically it's a team per context and a context per team. That's typically how it works. And teams can't be too big. Now, 10 people is sort of big. 3 or 4 is easy. 10 is difficult. 100 is impossible. You break it up into more teams, right? We all know this. And he says that's true of bounded context. And so, and that fits with Smalltalk as well. There have been groups where they would have a huge number of people working on a single Smalltalk image. Very difficult, very difficult. Takes lots of discipline, lots of rules. That's not natural for Smalltalk. So your application you build, of course, conforms to the standard class library. And Smalltalk is pretty good, actually, at building anti-corruption layers. That's a lot of, when you hear stories of old-timers telling you about how they hooked up to this system, how they hooked up to that, so they built a model of this system, and they were able to bring stuff in. They're actually building anti-corruption layers for whatever system they were talking to. Smalltalk's good at that. It's not so good at building anti-corruption layers for other Smalltalk libraries, because there's like too much interaction between Smalltalk. It's too hard to protect yourself from other Smalltalk code that's in your image. And I mean, we have ways of dealing with that, but it just isn't ideal. And that's because, like I said, Smalltalk excels at making a single bounded context and anti-corruption layers to the outside world, but does not excel at doing it inside. Okay, so my conclusion is that what we need is a focus on defining interfaces to the outside world. And again, there are systems out there that do this already, and the commercial ones do more than the non-commercial ones. So they're sort of in advance of that. But that, we all say this is actually relies on the strength of Smalltalk. We are focused on what Smalltalk is really great for. And we want to define interfaces for all these different things out there. I mentioned Docker. I've been using Docker recently. It's a very cool system. I think it's sort of the systems like that are the future of big software systems. And one of the problems is when you're running a Docker image, I was going to say, I think it's a Docker component, I think is the right word. It's hard to debug them. Actually, if they were in Smalltalk, if you could attach to them and go in and run the debugger, your world would be so much better. As I'm using it, I keep saying, Smalltalk would really fit nicely into this ecosystem. It would be a great way to build these components. But if we're doing that, one of the things that's going to happen is you start off with one image and you've got a library and you're building it and you've got 4 people and 5 people and 6 people. Now you realize, this ought to be a whole other thing. We need a way of taking an image, taking something built in one image and splitting it into 2. And the converse is sometimes you just discover that you don't really need to have these things be separate and you want to join them. Those are kind of refactorings, big refactorings that we don't think about now. But we need to have tools, techniques for doing that. And we need tools for managing, coordinating images running. When we talk about interfaces, there already are these different specification languages for interfaces, and we want to support them. We shouldn't be trying to invent new ones. We're too small a community to be inventing new ones. We want to support them. And the specifications are more than just the old IDL, here's some data, here's operations on the data. We really want to have the specifications that talk about security issues and reliability issues, because if you're trying to make a system that is reliable, it means machines will go down. Well, if a machine goes down, an image on that machine will go down. If you have it split off into different images, there's going to be images in other machines, and they're going to stay up. So being able to talk about what's up, what's down, how you control that, that's part of the reliability, and we need to have that in our interfaces. And the low-level stuff, being able to actually debug, put breakpoints, change the code on an image. Again, Smalltalk is good at stuff like that. So if we go this way, if this is the way we think about things, then then Smalltalk is going to integrate well with all sorts of web technology. One of the problems we've had is that Smalltalk doesn't integrate well with C libraries. Now, we do things to try to make it integrate with C libraries, but it's always painful. And now there's Java libraries. Well, it doesn't integrate too well with Java libraries. With libraries, per se, different languages. But the whole web service world is a whole new way of reusing and building stuff that and there's no reason Smalltalk can't work really well with them. Since the one is too hard for us, we should do the one that is easier and get really, really, really good at it. And microservices is sort of the thing people talk about now. That could be the Smalltalk killer app. We could be the world's best at making microservices. So that's my vision of how. I'll just say something that I made a comment in the beginning about how Smalltalk made a mistake that had a huge influence. This idea that you have one world of objects is classic and object-oriented. That Java does the same thing. Pretty much all the object-oriented languages have this notion of trying to make all object access be transparent and unique. And it's a natural, attractive idea. It takes experience to discover that it doesn't scale. It's good at a certain scale. It's not good at a bigger scale. And just as Smalltalk maybe led the rest of the world astray, we can perhaps fix that and lead people on a correct path. That's my talk. Thank you. Okay. Yeah. So I was particularly interested in people who are already doing things like this. If people want to point out things, they say, "Oh, but we're already doing." I know that there are people working on stuff like this. But if you got another question,
yeah, just to make sure, you made a point that there should be many interfaces, small together, have interfaces like so, Docker, and so on. I also think that the important point is that there should be the interfaces, other systems into small. And I just want to make sure that we actually need that explicitly.
well, when I'm mentioning SOAP, of course I mean that you should be able to use SOAP to call Smalltalk objects, just as you're using, a Smalltalk image should be able to say, here's my SOAP interface, and you want to declare an interface and say what it is that you're being able to do, and then people can make calls to you. Absolutely, that's what I'm saying. Yeah.
So I'll mention too, since you asked about people that are doing something kind of like that, I'll just mention the E language and some of the languages that follow after that.
Yeah.
I did give a talk here last year about possible ways to apply some of these concepts to small.
Yeah. So there are various researchers or other languages where they understand these things as being important and try to go there. But I'm actually talking about how do we put that in Smalltalk? How do we do that? And I know that with like with VisualWorks has the ability to have a web service that's running headless that you can. You're in a different image and you can be looking at the code that's over on that image, and you're in this image and you can debug the other image. And even with Gemstone, the very fact of having this database, the objects over on Gemstone is good actually at saying you're in a Squeak image or a VisualWorks image, and these are my local objects, and then you have proxies to objects over on Gemstone, and you can sort of control, is a method running on the proxy or is it running over there on the server? You have ways of controlling that. So in Gemstone, you do think about different object spaces, and it has ways of managing that. So that's the sort of thing that I think is the future. Instead of being just something that appears in a few places, it really should be our usual way of operating. Any more?
Okay, thank you. Great talk.
Okay, turn this